the Breguet 941, which has been flying since June 1961. This prototype of the 188 is the only true STOL transport flying today. It has exceptional short takeoff and landing characteristics, while at the same time it exhibits positive control about all axes at very low speeds and unparalleled engine-out safety. With these characteristics, the McDonnell 188 can deliver an 8-ton payload almost 500 nautical miles, land over a 50-foot obstacle into a 1,000-foot strip, and return with a 4-ton payload without refueling. The basic design concepts which make the outstanding low-speed performance and safety possible are a wing totally immersed in propeller slipstream, triple-slotted full-span flaps, differential control of the pitch of the outboard propellers, and mechanical interconnection of the 4 propulsion units. The aircraft is powered by 4 free-turbine engines, spaced so the combined propeller diameters cover almost the entire wingspan. The propellers are not driven individually by the corresponding engines. All 4 engines drive a common cross-shaft system, which is in turn geared to the individual propellers, driving them at a uniform RPM. Thus, if one engine should fail, all 4 propellers are still driven. There is no disymmetrical yaw force, and although power is reduced 25%, total thrust loss is only 17%, since propeller efficiency is increased by reduction of power loading. Correspondingly, if a propeller should fail, there is no loss of total installed power, since all 4 engines still drive the remaining 3 propellers. In the event of an engine failure on takeoff, the takeoff distance is increased only 8%. The pitch of the inboard and outboard propellers can be differentially controlled by a switch mounted on the single power lever. The pitch of the outboard propellers is also differentially controlled by the pilot's control stick when the landing flaps are deflected. The resulting change in slipstream velocity over the outer wing panels provides the positive control at low speeds which is so unique to this aircraft. Propeller pitch control is entirely hydromechanical. No electronics are involved. To make use of the deflected slipstream principle, the 188 has large full-span flaps. These flaps are triple-slotted. They have rearward travel and can be deflected downward to an angle of 100 degrees. Being totally immersed in the propeller slipstream, they provide the high lift needed for STOL operation. For example, at a weight of 51,600 pounds, the Model 188, powered by 1,500 horsepower engines, has a landing roll of less than 450 feet. And on a 103 degrees Fahrenheit day, it can land over a 50-foot obstacle in less than 950 feet. The 188 overcomes the difficulty of obtaining effective lateral control in the low dynamic pressure of STOL flight by a combination of large flaps, spoilers, and differential pitch control of the outboard propellers. This pitch control is linked to the lateral control when the flaps are down. As the aircraft turns, the pitch of the outboard propeller increases on the outside of the turn and decreases on the inside of the turn. The combination of immersed wing with high lift flaps, spoilers, and aileron propeller pitch tie-in enables the 188 to perform high roll rate turns at very low airspeeds. In this scene, for example, the prototype, the Breguet 941, is at a gross weight of 38,000 pounds and at an airspeed of 50 knots. The unusual repeatable landing accuracy of the 188 is the result of several design features. The 3 degrees incidence of the wing, coupled with a 3-degree angle of attack used during the landing approach, causes the fuselage to be parallel to the flight path. This permits the pilot to aim the airplane at the intended point of touchdown. The paravisual lights, operated by the angle of attack sensor, indicate the proper angle of attack and hence speed to the pilot. The large flap deflection, combined with an approach power setting of 60%, produces a high lift, high drag condition, which allows a 9-degree approach angle, 3 times steeper than other transports. Approximately 40% of the lift being generated during the approach results from the 60% power setting. The approach angle is controlled by varying the flap deflection between 75 and 100 degrees, which controls the drag. Power is never varied during the approach. It is held constant to the touchdown point. The aircraft is never flared. Instead, it is rotated just before touchdown to place the landing loads on the main landing gear. Thus, touchdown occurs at the point of intersection of the flight path and the ground, producing a high degree of landing accuracy. At the instant of ground contact, the reverse propeller pitch is activated and the power lever advanced to 100%. This produces full reverse power within 1 second. Because the cross-shafting assures symmetrical thrust from all propellers, maximum reverse power can be rapidly applied on the landing roll without causing yaw. The McDonnell 188 has flight-operable rear cargo doors for in-flight delivery of large items. It can accommodate 55 troops. With the integrally installed landing gear jacking feature, the cabin floor can be raised or lowered to mate with truck beds of various heights. The 8.5-foot width of the cabin and the payload capacity permit the 188 to carry more than 90% of all the wheeled and tracked vehicles of a road airborne division. The aircraft's rugged trailing arm landing gear, which provides for fore and aft as well as vertical motion of the wheels, makes the 188 well suited to operation from crewed assault landing strips. The gear rolls freely over ground irregularities. The control stick, along with the pilot's single power lever for operating the 4 throttles, makes the 188 as simple to fly as a single-engine aircraft. It is also equipped with cheek windows to provide the pilot an unobstructed view of the ground immediately in front of the aircraft. This is particularly helpful for taxiing on rough ground. Although operations in 20-knot crosswinds have been demonstrated, they are not required when it is possible to take off diagonally across a runway, as was here demonstrated to personnel of the United States Air Force, Army, and NASA at Villacoublay on the outskirts of Paris. Landing with one engine inoperative has no effect on the approach speed, approach angle, or landing. Feathering a propeller, however, requires a slight increase in approach speed. At touchdown, the corresponding opposite propeller is feathered to maintain symmetrical reverse thrust braking on the landing roll. If a go-around is necessary, there is no loss of altitude. Application of full power almost immediately checks the descent. Because of the tie-in between the throttle and the longitudinal trim, the aircraft assumes a normal climb angle. This can be accomplished with hands free of the flight controls. The McDonnell 188 meets all the requirements for a tactically effective short takeoff and landing assault transport. It can carry a payload of more than 8 tons and transport more than 90% of the vehicles in a road airborne division. It can land with a ground roll less than 450 feet at its maximum landing weight and can maneuver with positive control at airspeeds as low as 50 knots. These features permit the 188 to meet the needs of the soldier in the field. It can deliver the food, the ammunition, the POL, and the equipment without the expense of large, heavy-duty forward airstrips, or without the time-consuming, costly paradrop. The McDonnell Model 188 can be the vital tactical link in the airline of communication. With this aircraft, the exacting requirements of a STOL assault transport have been convincingly demonstrated. low speeds, and unparalleled engine-out safety. With these characteristics, the McDonnell 188 can deliver an 8-ton payload almost 500. It has exceptional short takeoff and landing characteristics, while at the same time, it exhibits positive control about all axes at very low line. Concepts which make the outstanding low-speed performance and safety possible are a wing totally immersed in propeller slipstream, triple-slotted full-span flaps, different nautical miles, land over a 50-foot obstacle into a 1,000-foot strip, and return with a 4-ton payload without refueling. The basic design is the Breguet 941, which has been flying since June 1961. This prototype of the 188 is the only true STOL transport flying today.